All right, so our next lesson is kind of just the beginning of the rest of this chapter, where we're trying to figure out how can we actually solve a quadratic. So we've looked at the graphs, but now we want to kind of apply what we did in chapter 8 with factoring, and then move forward with what ways can I find the solutions depending on what I've given. So let's kind of review where we've been, and then we can move into what we will learn throughout the next few weeks. So first off, we really haven't done a lot of solving with factoring. We have discussed it, but that's the first way in which we've kind of approached this solving idea. To solve by factoring means to put something in that factored form, then use the zero product property, which is straight out of chapter 8. So, yay, red light, green light. So this is a green light problem since our leading coefficient is 1. So we would like to find the factors of 5 that add to a negative 6. Well, since 5 is prime, that should just be 1 and 5. But we have to ask ourselves, what should the signs be so that two numbers multiply to a positive and add to a negative? And in that particular case, it means they're both negative, so that we get negative 6. So the factored form of this should be x minus 1 and x minus 5. However, so that we don't forget that we're actually trying to solve this, we need to make sure we continue to set this equal to 0. So let me give myself a little bit more room there. Equal to 0. All right, so we ask ourselves, if two things multiply to 0, what could x be to make either one of the portions 0? So our zero product property asks, when will x minus 1 be 0? And when will x minus 5 be 0? And that answer is at 1 and 5. So that's how this process has looked up to this point. Now that we've done a little bit with parabolas, and as a heads up, anytime you'll tackle solving with a parabola, you would only really choose that method if the graph was already created, or eventually in the future if you possess a graphing calculator that you could use. So, the way that we will solve by graphing is we will take a graph that's already given to us, and we're going to look for that graph's x-intercepts. So, if you look here, this is the graph of the same thing we just solved with factoring, y or x squared minus 6x plus 5. If we go to where it crosses our x-axis, so as a reminder, our x-axis is our vertical axis. If we look at where it crosses at 1 and 5, which matches the solution we just got when solving by factoring, meaning multiple methods to accomplish the same end game. Now, if you have a graph, solving by graphing is typically the easiest unless the points where it crosses the x-axis are not easy to determine. So maybe they're a decimal of some kind, or they're not physically on the graph where you can see it. However, in the future, if you were to possess a graphing calculator or wanted to graph these by hand, which you don't need to, but if you wanted to, the process of determining the solutions by a graph is to first place your equation in standard form, meaning you have it set up equal to 0. And we discussed back in chapter 8 why this is a 0, but let's revisit that. The reason we have it equal to 0 is because of the fact that since the x-intercepts are the solutions, we want the y values to be 0, because if we're on the x-axis, that means our y-coordinate is 0. Now, once you have it graphed, your goal is to search for those x-intercepts. Now, as a heads up, because sometimes this can be confusing, and yay for vocab and math being tricky, but they actually have multiple ways to refer to these solutions. So sometimes they ask for the x-intercepts. Sometimes they ask for the zeros of the graph. And sometimes they ask for the root of the graph, or the roots. So just be aware, when solving a quadratic, sometimes you could see all three of those terms used, and they are actually all referring to the same thing. Now, since we are solving a quadratic, which means degree 2, that means the most times that the parabola would cross the x-axis is twice. So we're going to kind of look at a different situation for each number of possible solutions. So first, let's tackle a graph that crosses twice. So if you were eventually the owner of a graphing calculator, or you wanted to use Desmos, which is on your iPad, to enter this into your calculator, you first need to put it into standard form, which would mean moving this 3 to the other side. So if we subtract it over, what you would enter into Desmos would be x squared minus 2x minus 3. And you would set it equal to y. Then once you graph it, your goal is to determine where does it cross. Again, in your homework, when you get to the last page, these graphs are already done for you. So please don't graph something you don't need to. All right. So if we look at the values, the x values where those cross, or our roots or our zeros, we would say the answer to this graph, or the solution to this quadratic, is at -1 and at 3. And it's as easy as that. So if you're given a graph and you're asked to determine the solutions, you're just looking to where the graph crosses the x-axis. Now, it is possible that a graph has its vertex on the x-axis. We call this a double root, meaning it doesn't actually cross more than once, and if you were to solve it, you would get the same number twice, hence what we call a double root. Now, if you wanted to put this into a graphing calculator, you would first need to put this into standard form, meaning we need to move everything to one side. So we would move this 2x over here, and we would get 0 equals x squared minus 2x plus 1. After graphing it, which would look like this, we would ask ourselves, where does it cross the x-axis? And touching it does count as that, which means our solution in this particular case is just at 1. So you could have two solutions. You could have one solution, which begs the question, is it possible to not get a solution? So it is possible to have a graph that doesn't cross at all. So if you wanted, again, to test this out and do your own graphing, step 1 is to put this into standard form. Once you have it graphed, if you realize that it never crosses, then your answer is no real solution. Now, you may wonder, why does it need to be real? So for right now, we're just going to state that this has no solution. Eventually in Algebra 2, you're going to learn how to work with what we like to call a complex solution, which isn't real. And when you get there, you'll understand more why we put no real solution instead of just no solution. So if you're solving by graphing, and you get to a parabola that does not cross the x-axis, you just write no real solution. And that